Welcome to the Chemistry, Biology and Math Revision Hub. Today we are doing the Pearson Edexcel International A-Level Chemistry Unit 6 for January 2023. Let us begin with the first question. Question 1. Solution A and solution B are aqueous solutions. The compound in each solution contains one cation and one anion. The cations are different but the anions are the same. Both solutions are green. They say give the formulae of 3 cations that would be responsible for the green color. This is going to be either nickel 2, chromium 3, or iron 2. You could write them in this manner or in their hydrated manner. In part B, a student added dilute aqueous sodium hydroxide drop by drop to samples of each solution. Initially, a green precipitate formed in both solutions. More aqueous sodium hydroxide was added until the sodium hydroxide was present in excess. The precipitate produced from solution A was insoluble and turned brown on standing. If it turned brown on standing, then it means it was iron 2, which is converted to iron 3. Then they say the precipitate produced in solution B is dissolved to give a dark green solution C. This is going to be chromium 3. Then they said, give the formula of the green precipitate from solution A. This is going to be the formula because remember we added sodium hydroxide dropwise, so 2 of the water ligands have lost their hydrogen ions to become OH, which is that. The next they say, give the formula of the species responsible for the dark green color in solution C. This is going to be hexahydroxychromate 3, which is this one here. In part C, the student added hydrogen peroxide and warmed the mixture which turned yellow. The yellow solution was boiled to remove excess hydrogen peroxide, cooled, and then pure ethanoic acid was added drop by drop. The yellow solution gradually turned orange. That is because chromate became dichromate due to this reaction here. The acid provided the hydrogen ion that converted chromate 6 into dichromate 6, and water is going to be produced as well. So they say, state the type of reaction involved when the dark green solution turned yellow. That is going to be a redox reaction because chromium 3 is going to be oxidized to chromate 6 and hydrogen peroxide is going to be reduced. Then they say, identify by name or formula the ion responsible for the final orange color of the solution. This is going to be the dichromate ion. And here they say pure ethanoic acid is corrosive. Identify the appropriate control measure to reduce the risk associated with this hazard. Assume the student carried out the addition in a fume cupboard wearing safety glasses and a lab coat. Because it's corrosive, they had to wear gloves. The next they say, describe the corrosive hazard label present on a bottle containing pure ethanoic acid. You may use a diagram in your answer. Here I chose not to use a diagram, I just used a description. So in the corrosive hazard symbol diagram, there are 2 test tubes with a liquid dripping out of them. There is a hand and a piece of metal and the liquid drops on them. Moving on. In part D, the student attempted to identify the anion present in the green solution A. The student added dilute nitric acid and a few drops of aqueous silver nitrate to about 2 centimeters cubed of solution A. A pale precipitate formed which the student thought might be a white or cream color. Identify by name or formula 2 anions which might give this precipitate. The precipitate could be either chloride or bromide. The next they say, the precipitate formed in D1 was separated from the mixture and aqueous ammonia was added. Describe how this test allows the student to distinguish between the 2 anions. In silver chloride, the anion is chloride and here the anion will be bromide. So in silver chloride, there will be dissolution in aqueous ammonia as well as in concentrated ammonia. But in silver bromide, dissolution will only occur in concentrated ammonia. And the next part says, explain why with solution A, the precipitate must be separated before adding aqueous ammonia. This is because you remember it was a green precipitate. This will not dissolve in excess ammonia. Also, the dissolution of the silver halide is going to be masked by the green color. So this brings us to the end of question 1. Let's continue to question 2. Question 2. The reaction between the tertiary halogenoalkane 2-chloro-2-methylpropane and hydroxide ions to form 2-methylpropan-2O is shown, which is that reaction. They say the progress of the reaction can be followed by titrating portions of the reaction mixture with a solution of hydrochloric acid of known concentration. An experiment to determine the order of reaction was carried out. The procedure is as below. In step 1, a flask containing 250 centimeters cubed of an ethanolic solution of 2-chloro-2-methylpropane with a concentration of 0.1 mole per decimeter cube was placed in a water bath at 25 degrees Celsius. A similar flask containing 250 centimeters cubed of aqueous sodium hydroxide with a concentration of 0.1 mole per decimeter cubed was placed in the same water bath. The temperature of each solution was allowed to reach 25 degrees Celsius. And in step 2, 7 conical flasks were prepared, each containing about 50 centimeters cubed of propanol. In step 3, the reaction was started by mixing the two solutions from the water bath in the large flask. The flask was returned to the water bath, and a timer was started as the solutions were mixed. In step 4, at intervals, 25 centimeters cubed samples of the reaction mixture were transferred to the conical flask containing propanol, and the time was noted. In step 5, each sample was immediately titrated with a solution of hydrochloric acid of concentration 0.05 mole per decimeter cubed, using methyl orange as the indicator. So the first question says, give the expected color change at the end point. The color is going to change from yellow to orange. And next they say, explain the effect on the volume of hydrochloric acid required if the titration was not carried out immediately after step 4. If it was not carried out immediately, then the volume of the acid required would decrease because the reaction would still continue, though at a lower rate. Next they say, explain how the use of aqueous ethanol in the reaction mixture allows the reaction in step 3 to proceed at a relatively fast rate. A description of forces involved is now required. Ethanol is going to act as a solvent to allow both reactants to interact with each other for the reaction to proceed faster. So I said, ethanol is a solvent that can dissolve both 2-chloro-2-methylpropane and sodium hydroxide. This allows the two reactants to interact more in similar solvent cages for more collisions to occur. If more collisions are successful, then the rate of reaction is going to be faster. In part B, an experiment was carried out using this procedure and the results are shown. So we have the time as well as the volume of HCl. Then they say, plot a graph of the data using the axis given. So I'm going to use this information to plot this here. We have the volume of HCl on the vertical axis and we have the time on the horizontal axis. So I used the data in the table to find a suitable scale for both the horizontal as well as the vertical axis and then plotted the specific points. Moving on. Here they say, determine 2 successive half-lives for the reaction. You must show your working on the graph. So I determined 2 successive half-lives, which are this one here and that one there. I began with that to that, giving me 1730, and that to that, giving me 1700. So here I wrote my answers. And next they say, state the order of this reaction and justify your answer. This is first order because the half-lives are similar or they're almost similar. 2 half-lives are acceptably considered to be similar if the range is plus or minus 150 seconds. So this brings us to the end of question 2. Let's continue to question 3. Question 3. Moss in lawns can be treated with lawn sand, a mixture that contains sand and a double salt, ammonium iron 2 sulfate, which is that. The percentage by mass of iron 2 plus in the mixture can be found by titration with a solution of potassium magnate 7 of known concentration. The procedure is as below. 4.5 grams of lawn sand was accurately weighed in a 250 centimeters cubed conical flask. The sample was shaken with 50 centimeters cubed of dilute sulfuric acid, which is an excess. The resulting mixture was titrated with potassium magnate 7 solution of concentration 0.0200 mole per decimeter cubed. The titration volume was 40.35 centimeters cubed. The first question says, state what will happen in the titration if the mixture was not acidified. If it was not acidified, then manganate 7 will be partially reduced to manganese 4 oxide. Then the next part says, neither hydrochloric acid nor nitric acid can be used to acidify the titration mixture. For each acid, give a reason why it cannot be used. Nitric acid would oxidize iron 2 to iron 3. Also, chloride ions in HCl would be oxidized by manganate 7 ions. In part B, the ionic half equations for the reaction of the iron 2 ions and the manganate 7 ions are shown. So these are the reactions. They say calculate the percentage by mass of iron 2 plus in the sample of lawn sand. So here I was given that equation and that, and since we have 5 electrons here, I multiplied everything by 5 to create 5 electrons here as well. And then you can see the ratio is going to be 5 to 1. So since we have the information for magnet, concentration is 0.02 and the volume is 40.35. So moles of potassium manganate or manganate are going to be concentration times volume, which is 0.02 times 40.35 divided by 1000. We convert this to decimeters cubed, and I got that as the number of moles of potassium manganate. When we look at the mole ratio of manganate to iron, it's going to be 1 to 5. So the moles of iron are going to be 5 times the moles of potassium manganate or manganate, which is going to be 5 times this, giving me 4.035 times 10 power negative 3 mole. Now the mass of iron is going to be the number of moles times the atomic mass, which is going to be that times 55.8, giving me that. So the percentage by mass is going to be this mass here divided by the original mass, which was 4.5, times 100, giving us that, and I rounded off to 5%. So that is the answer. In part C, the titration is carried out using the apparatus shown here. That is a burette, that is a conical flask. They say at the end point the solution changes to a permanent pale pink. To repeat the experiment, the burette is refilled with potassium manganate 7 and the procedure carried out again. Give 3 ways in which a titration is carried out to give the most accurate possible burette reading. Assume the equipment is the same, the burette is clamped in a vertical position, and the titration volumes are read at eye level from the bottom of the meniscus. As you're approaching the endpoint, add potassium manganate drop by drop and then swirl. Then you should place a white tile below the conical flask so that you can see the endpoint color clearly. Remember, this is a pale pink color. It's going to be hard to visualize. Then you should have rinsed the conical flask and the burette with the ionized water, and then rinse the burette with potassium manganate as well. You should also use a black card behind the burette to clearly read the meniscus. So this brings us to the end of question 3. Let's continue to question 4. Question 4. The compound 2-ethanoyl aminobenzoic acid can be prepared by the reaction of 2-aminobenzoic acid and ethanoyl chloride. This is 2-aminobenzoic acid and this is ethanoyl chloride. They heat under reflux and then produce the product as well as HCl. So this is the procedure. Add 5 grams of 2-aminobenzoic acid and a few anti-bumping granules to a dry 100 centimeters cube pear-shaped flask and feed a reflux condenser. Then in step 2, add 10 centimeters cubed of ethanoyl chloride, which is an excess, by pouring it slowly down the condenser. In step 3, gradually bring the mixture to boil and heat under reflux for 15 minutes. Then in step 4, allow the mixture to cool and slowly add 10 centimeters cubed of water down the condenser. In step 5, heat the solution slowly until boiling. In step 6, allow the solution to cool to room temperature. Then collect the crystals of 2-ethanoyl aminobenzoic acid by filtration under reduced pressure. In step 8, recrystallize the impure product from a mixture containing equal volumes of ethanoic acid and water. The first question says, give 2 reasons why it is often necessary to heat a reaction under reflux as in step 3. Because they said heating and they said under reflux, I want us to underline the part heating or heat and then under reflux. The heating increases kinetic energy so that more collisions occur, so that the rate of reaction can increase. Then when we use a reflux condenser, this allows for volatile reactants to return to the pear-shaped flask for the reaction to go to completion. Moving on. In part B, explain why in step 4, water is added slowly to the cooled solution. Because there is an excess of ethanoyl chloride, this reacts violently or vigorously with water. So I said water reacts with excess ethanoyl chloride, and this reaction is volatile or vigorous. So slow addition prevents excess heat release from the exothermic reaction, so volatile substances are not lost. Also, HCl gas can be produced at a faster rate if water is not added slowly to the cool reactor contents. The next part says, draw a label diagram of the apparatus used for filtration under reduced pressure in step 7. To filter under reduced pressure, you need a Bashner funnel. So my setup is like this. You need to put a filter paper, it has to be flat inside the funnel. And then you need to put a connection or a tube connecting to the pump in order for suction to be achieved so that the substance on here can be able to dry as the liquid drops in here due to the pressure created in this area. Moving on. In part D, the melting temperature may be used to confirm the identity of the crystals. Draw a label diagram of the apparatus you would use to measure the melting temperature. I would use a thin tube. This is the tube. We have mineral oil inside, the place where you're going to heat. There is a thermometer that is tied to a capillary tube so that the sample can be placed inside the capillary tube in order for the temperature to be detected by the thermometer. Down here they say, set how this melting temperature determination would show that a pure sample of 2-ethanoyl aminobenzoic acid had been prepared. So it would have a sharp melting point, and the melting temperature would match that in the data booklet. In part E, show by calculation that in the preparation, 10 centimeters cubed of ethanoyl chloride is an excess compared to 5 grams of 2-aminobenzoic acid. So here I began by calculating the mass of ethanoyl chloride, which is density times volume. We have the density and we have the volume here, so it came out as 11 grams. Then the moles of ethanoyl chloride are going to be mass divided by the molar mass, which is going to be 11 divided by 78.5, giving me that as the number of moles of ethanoyl chloride. Then the moles of 2-aminobenzoic acid are going to be mass divided by molar mass. This is the mass given to us, and the molar mass is that, so the number of moles are these. Based on the equation, the mole ratio is 1:1. We can see this is lower than that, and we can conclude that this is going to be in excess. So I say 0.140127 mole is greater than 0.036496 mole, so ethanoyl chloride is in excess. In part F, a student carried out the preparation using the amount of reagents given in E and obtained a yield of 56.7% of ethanoyl aminobenzoic acid. Calculate the mass of 2-ethanoyl aminobenzoic acid obtained. So the molar mass of 2-ethanoyl aminobenzoic acid, I calculated it using the information above and I got 179 gram per mole. Also, the moles of 2-ethanoyl aminobenzoic acid are going to be that from above. So the mass of 2-ethanoyl aminobenzoic acid is going to be number of moles times molar mass, which is that times that, giving us 6.532784 grams. And the percentage yield, which is 56.7, is going to be the actual yield divided by the theoretical yield times 100. So making X the subject, I got 3.7 grams, or you can say 3.70 grams if it's written to 3 significant figures. So this brings us to the end of question 4, as well as to the end of the whole paper. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.